Okay, when it comes to graphing linear equations, there's a whole bunch of tricks of the trade you can use. And what I'm going to do is show you two of the most common ways. And I don't care which one you pick, but it'd be a good idea to be able to do both of them, because sometimes one way is a lot quicker than the other, depending on how the function is written or how it's organized. So let's take a look at the blue side over here. A lot of people would take this and try to make it look like y equals mx plus b. Slope-intercept form, and that's fine. If that's what you want to do, go right ahead and do it. Okay. So what we'd do is we would start by subtracting 2x over to the other side, and we get 3y equals negative 2x, don't forget about the negative, plus 12. And we divide by 3, and that makes one of these numbers better and one of them worse. Y equals negative 2/3 x plus 4. Okay, now if that's the way we're going to do this, positive 4 means I'm right here. Okay, and my slope is negative 2/3, so I go down 2 from there and over 3, and I get something that looks kind of like that. Okay, and that's absolutely fine. Now it's not going to be perfect because I didn't draw my graph to scale, I just kind of sketched them. So it won't be exact, but if we graph this with a different method, it should still turn out to be the same graph, go in the same direction, in the same place on the axes. Okay. So let's look at another way to do this. Since I have this in what's called standard form, which means x and y are on the same side of the equal sign, see there's my equal sign right there, I can do what's called an intercepts chart. Okay. And here's how I do it. Some of you are much better at this kind of thing than others. I'll do xy chart, and all I'm going to do is find 2 points where they cross each axis. Now this isn't all that complicated. I'm going to plug in 0 for x and see what happens. Okay? So I put in 0 for x, I get 2 times 0 plus 3y equals 12. And the nice part about this method is you can do a lot of it in your head. We know that's going to equal 0, so I get 3 times something is 12. Y has to be 4. Oh, notice, hey, that's a spot that's right there on that graph also, 0, 4. Okay, I'm going to put it right here. And then, okay, that's 1 point. Now how about the other one? Without knowing that the blue stuff is over here. Well, if we put in 0 for x and got a point, let's try putting in 0 for y and getting a point. Put in 0 for y. All that means is I rewrite my equation. 2x plus 3 times 0 equals 12. And that means I'm going to have to take that out because it's something times 0, and I get 2x equals 12, x has to be 6. So I need to find 6, 0. 1, 2, 3, 4, 5, 6, 0. Okay. And then when I connect those, what do you know? Basically the same line as I have over here. Okay. Each method works. Each method is mathematically accurate. Take your pick. Okay. Now personally, if the equation looks like it's going to be really fast and simple to put into that method, that's the one I use. But if the equation, if I look at it right from the start and I go, you know, 2 and 3 both go into 12, okay, that's going to be kind of easy to work with, and they're both on the same side, I just automatically go for this. Okay, you have to get kind of a feel for what's going to be quicker or slower, but it really is up to you. Both methods will work with every line. The only time you get a line that doesn't work with this method right here is a line that goes through the origin, because we only get 1 point by using that format. We'd have to eventually find a second point.